So they've got the graph of j of x. We want to translate it 4 to the left and 5 units down. Now on mine, I can just trace it perfectly and move it with my finger, but that wouldn't be a very good way of showing you how to do it, because if you tried to do that on your page, you'd just probably get pencil on your finger. What we'll do is we'll take some key points. This is a key point, this is a key point, and that's a key point. Now let's take those points and move them 4 to the left and 5 down and see where we end up. So this first one here, 1, 2, 3, 4 to the left, 1, 2, 3, 4, 5 down. That point would go there. The one that's the x-intercept that's at 2, when you go 4 to the left and 5 down, ends up there. And the one that's at a half, the maximum, if you go 4 to the left and then 5 down, would end there. And then you want to have the same shape as you had before. In your textbook, anytime that the graph hits the end, they just have it end. It should have, for them, that's their indication that there's arrowheads, that that graph continues forever. You're responsible to put arrowheads on your graph. On your provincial final exam, if you forget arrowheads once, we have to bubble in an error on the answer sheet that you made an error of forgetting arrowheads, and you lose a half a mark for that. So we're going to be diligent about doing arrowheads just to practice that, because it's not something that you'd want to lose a little half mark on the final exam. So there we go. We've moved the graph 4 to the left and 5 down. Now we want to write an equation. Again, here's this language again. Equation of the image graph in terms of the function j. So we have to decide what'll be inside the function, what's outside of the function, how that's going to work. And so our green graph inside of the function moves things left and right. We've moved it 4 to the left. So how do I write that inside the function? X plus 4. So we've got the opposite. Again, everything that's left and right is opposite. So if you moved it 4 to the left, then you'd have a plus 4 inside. And then the 5 down would be minus 5 in the end. Domain and range of our original red graph. And then we'll do domain and range of our image graph as well. Again, domain are the x values. And when you're trying to figure out domain, I often find it easy to think, does it have a smallest value? And what is that smallest value? The smallest x value. Now on our red graph, we have an arrow on this graph. You have to imagine that it keeps going up forever, and it'll keep going to the left forever.
For the grade 9 English students that need to be going to the theater, the pre-grade IB grade 9 students, they need to be in geo.
So because it goes up forever and it would continue going to the left forever, it has no minimum value. The other thing you would look at, does it have a maximum value? Again, on the other side of the graph, it's going up forever on the right-hand side, and that would mean it's getting wider forever that way as well. So it includes all x values to the negative side and all x values to the positive side. So the way that we would write that is that our domain is everything. Now that's our set notation for writing the domain as everything. In interval notation starts with the smallest value. Since it doesn't have one, we'd say it starts at negative infinity and goes to infinity.
So the second one is
It's called the interval notation. Yeah. And with that interval notation, every time you use infinity, we used round brackets. The difference between round and square brackets in interval notation, square means the value is included, but infinity isn't really a value that you can include, so they use the round brackets for that. Yeah.
We didn't we also use the square brackets, but it's not included.
But square the other way, yeah. That's in French as well, they do that with the brackets flipped the other way, which makes sense as well. So now for the range, again, start thinking, does it have a smallest value? So if I'm looking at my y values that come from the bottom up, sure enough, this one does have a smallest value for y, and it's 0. And then, does it have a maximum value? It goes up forever. So it has to be greater than or equal to 0. So that is how you'd write it in set notation. In interval notation, you always start with your minimum value, square bracket because 0 is included, and then it goes up forever, so you'd go to infinity.
We wrote in that case the R, which I like, it's a main, but then we wrote plus at the top to indicate it goes forever to positive.
Oh, okay.
Bottom we wrote 0 to indicate that the 0 is included. So instead of writing the main,
Right. And then domain and range for the green one. Again, you can maybe see that the domain is everything for that one as well. And that in interval notation you could write that as well. And then for the range, now it has been shifted down 5. Now my minimum value is at -5, and it does go up forever. So y is greater than or equal to -5, or you could write it as -5 to infinity. So the questions that you could do now from your homework are 8, 9, and 10.